Hello friends, welcome to my channel MEP Solutions. My name is Priyanshu Moria and today we will talk about toilet ventilation drafting. So I already explained you about designing in my toilet ventilation part 1 and part 2, that was ASHRAE standard and ASH standard. You can watch my videos, and now today we will talk about drafting, duct designing, how to place the disc valves. So what are disc valves? First let's see. So these are disc valves. Just behind that disc valve there will be your ducting. This type of disc valve we use. This is called air terminal devices. So here I have one project in toilet. I can't show you entire project. This may be copyright issues. This is one school building. Classrooms here we have. Preparation room, offices, visible. So here. So first of all I am switching off the layers. Unnecessary layers I'm switching off. Okay. See, here we have, I'm not switching off first. Here we have water closets 1 2 3 4 5 6 7 8 water closet. So from one water closet, from one toilet, we can say we can remove 50 cfm, because this is public type and this is continuous type. So what is the dimension here? It is 1.4 meter, and the length width is 0.9 meters. So yes, we can use the same as ASHRAE standard for continuous toilet. With public continuous, we can remove 50 cfm per unit as per ASHRAE. So 50 50 50 50 50 50. So 8 toilets we have, so 50 into 8, 400 cfm, and passage area is 9 meter by 1.87 meter. So see that length is 9 meter. These all are considered as a passage area because here we have wash basins, and the width is 1.87 meters. So 9 into 1.87, 16.83 square meter. 1 square meter is equal to 10.76 square feet. So we got 181 square feet. 1 square feet is equal to 1 cfm. Then we have 181 square feet is equal to 181 cfm. So in the toilet we are using a single disc valves for 50 cfm air removal cubic feet per minute, and in the passage area I am using 3 disc valves, so 181 divided by 3. So from each disc valve we will remove 60.3 cfm. From each disc valve 60.3 cfm. Total in the passage area is 181 cfm. So now we will switch off, we will off the layers. See, so everything is off here, not this one. Okay, so that name also I want to, and the symbols, doors. Okay, now it look better to work. Now first work is to place the disc wall. First we'll create disc wall. Let's create some layers for disc valves and exhaust air duct EAD, giving the color red, and another that is DV, disc valve, that is also red. So I'm creating disc valve. First use donut command, press DO, enter. So the disc valve sizes are here. I have one catalog, you can search on internet simply. So this is here, we have diameters, nominal diameter, outer diameters and inner diameters. So basically the disc valve will be of 100 mm diameter, and it may remove 12 to 175 cfm, and here we have pressure drops and its noise criteria. So for 60 and 50 cfm also we can use 100 mm of disc valves. So these are opening. E. If it is in the false reading, then it will be in minus, and if it is below the false reading, then the dimension will be in plus. So let's create a 100 diameter of disc valve. So I used donut command. It is asking specify inside diameter of donut. I am taking 0, enter. Now it is asking specify outside diameter of the donut. I am taking 75. Yes, 75, not 100. I am taking 75, enter, and the put here. Yes, here we have donut command, and now take a circle, see enter, center, and I am using D diameter. Diameter I am taking 100 mm. So it look like this. So it is looking some irregular path. So use RE recon command, enter. So see, now it becomes smooth. Now I am selecting this one and taking into the layer on top. So here we have disc valve. Now we will place that disc valve inside our toilet. First, let's divide our toilet. Here, this is the center line, and this is the center. Copy that disc valve, CO, enter. Take the reference as a center line. I'm picking up from the center and paste it very carefully here. Now remove this one, enter, again CO, enter. Now see here, I'm taking reference here at the corner. So here also pasting in this one. That was the reference point. So here we have disc valves in the toilets. Now the last toilet is of different size. So here also we have to take one line in the mid. I'm taking like this, and its midpoint is here we have. So it takes a little time. See, this one will be center. So CO, again I'm taking center as a okay. So now I placed disc valves. Now we'll place in the passage area also, and here I am using 3 disc valves. So I am using one line from here. Okay, what was the length here? DLI, enter. The length was 1770. So I am taking that exhaust air here, and I will use fresh air behind that exhaust air duct. Yeah, so here we have one line. I am using divide command, and 3 disc valves we require, so I am dividing it in 4 segments, 4, enter, but it is not visible, so press DDP type. So in DDP type I am using any one you can use. Here I am selecting this one. Okay, So 1, 2, 3 disk valves here we can place. So let's copy this one, CO enter, and now select this object, picking from the center point and place here. Okay, so now the another disk valve here and 3 disk valves in our passes area. Now delete that reference line, delete that. See, if you want to select all these symbols, then select one and select similar, enter. Everything is deleted. Now I'm taking one simple line, and now I will use exhaust air duct, EAD, and line. So from here I am starting the single line, and same from here I am starting the single line is till here. So now I will join all the lines from here to, this is SLD, actually this is the main duct and these are branches. So now we can copy and paste, copy here and paste on the another disk valve, and again repeat the process. It is a little bit boring, but you have to do. Okay, and now the last diffuser here, I'm extending this one till outside because the exhaust air will go on the roof. So we can place the fan here also, but it will not good because the smell of your building may enter into another building. So that's why we can't exhaust on the exposed wall. Now, so this is our single line diagram. So from each toilet is a 50 CFM exhaust, so we can write the text here, T enter, and here the text will be exhaust air CFM is equal to 50. So text is a little large, so we can decrease the size. So air exhaust air CFM is equal to 50 from each toilet. Now, so we may copy paste. So now here I placed all the disk valves, and I have given here passage area exhaust air CFM is 181 and fresh air CFM is 465 for entire toilet. Now, so this is our single line for exhaust air, and let's see one more ducting for the fresh air duct. I'm using here for fresh air, and for fresh air we can use diffusers. So see, these are diffusers, ceiling diffusers. We can use these diffusers for supply the fresh air in the toilet. You can see here this diffuser. This is also air terminal device. This diffuser is for air supply. It is for air conditioning. We may use for fresh air supply also. So here I am using 3 diffusers for fresh air. So fresh air from each diffuser will be 465 divided by 3, 155 CFM per diffuser. So let's find out diffuser size. So I will use beta software. There is one software for air terminal devices. Let's calculate the diffuser size. So this is beta software. Ceiling diffuser, SLD supply air duct. I am using for supply. I am using unit system Imperial, square shape VD quad, and NC max, that is noise criteria. I can take 30 to 35 in hospitals, so we can use 20-25 also. I am using here 30 decibel, that noise criteria, and CFM in each diffuser is 155, so I am putting here 155 CFM, and velocity is 500. That velocity is 500 FPM. That is design velocity for any air terminal device, for grill, for diffuser, for disc valves. So we use 500 FPM. Now find the nearest match. So it is giving size 9 by 9 inches of our diffuser size, that is a square diffuser size. This is the pressure drop. Here it is given 0.024 inches of water gauge. So 9 inches convert into mm, 9 into 25.4, 228. So 225 by 225 we can consider the size. So for fresh air I am creating FAD, fresh air duct, taking a green color, and one more layer I am creating for diffuser, F ceiling diffuser, FCD, FACD, fresh air ceiling diffuser, that is also a color green. Now close this one, and we will create that size was 225 by 225 if I remember. So now let's create. These all are exhaust air ducts. I'm giving into layer, and this was fresh air, so I will give it into the fresh air duct layer. Okay, let's create diffuser, fresh air ceiling diffuser. Take a rectangle and de-enter, just a second, rectangle, selecting a point, then de-enter. The size is 225, enter, 225, enter, select here. So this is our diffuser. You can measure the size. It is 225, and here also 225. Now let's do it offset, or enter, 25 mm offset in inside, and M enter for multiple times. Okay, so this is diffuser. Take a cross line, like this, and making in the layer, and now leader line for to show it is supply. So we will mirror it. So here we have the diffuser. Now this is color white, so we can convert that is also in green color. So press Ctrl 1 for properties, and here we'll have line color. It is color 9, so I am using green. So now you can save it, Control S, and use ARRAE command. So polar, and select here numbers 4. So 4 items I used. Okay, so this is our diffuser for fresh air. So here also I will divide that line in 4 parts to place the diffuser. DIV, enter, and I'm using 4 segments, so 3 diffusers, because here we are using 3 diffusers. So these 3 diffusers will place here. We can make it in block also. D, enter, pick point, selecting here, that is pick point, and this is diffuser 225 cross 225, and select the object. This is our object, enter. Okay, so now it is converted into block. Now CO, enter, select the object, enter, taking the reference line, and now here you can place. Now selecting that divide symbols, select similar, you enter. So all deleted. Now, so this size I'm adjusting here, and from here I'm taking the 150 mm. This is our duct. So this is basically our SLD, single line diagram. We have to mention the duct sizes also. So in my next video I will show you duct sizing, reducer sizing, and your fresh air ducting also. So thank you so much. So if you like this video, please like, subscribe, and share with your friends. Thank you.